A tidal bar is a sharp rise in free surface elevation propagating upstream in an estuary as the tidal flow turns to rising during spring tides. A tidal bar creates a powerful sound. The sounds are sometimes called a roar or a great destructive noise, often compared to the sound of locomotive train, bass drums, and thunder. The bar rumble can be heard far away because of its low frequencies. The first illustration presents the tidal bar of the Qiantang River, and the second, the tidal bar of the Chanson River. The acoustic properties of tidal bar were investigated in the Baie du Mont Saint-Michel in France and along the Qiantang River at Yanguan in China. They were further compared to physical experiments in a 19-meter-long, 0.7-meter wide flume at the University of Queensland. First, the sound record characteristics were analysed in terms of the sound pressure amplitude. The experimental results were matched closely with a simple source model in which the sound pressure is inversely proportional to the distance to the bar front. In the Chanson River bar at Yanguan, the mean sound levels reach more than 50 decibels during the passage of the bar in front of the microphone, with maximum sound pressure modulus up to 40 Pascal. Second, a spectral analysis of the sound records were conducted. The sound pressure spectra exhibited a dominant frequency, with the dominant frequency of approaching bar ranging from 50 to 100 Hz in the Qiantang River bar, between 50 and 120 Hz in the Chanson River bar, and within 200 to 600 Hz in laboratory bars. These values are summarized in this graph. The low-pitch rumble of the breaking bar has a dominant frequency close to the collective oscillation of bubble clouds. In a three-dimensional bar roller, the transverse vertical structure may control the air entrapment, and the tau perimeter wavelength, LW, is considered a representative length scale of the bubble cloud length. This is illustrated on this sketch and on this photograph of the tidal bar of the Chanson River in 2014. Third, the lowest natural frequency of the bubble clouds in the bar roller may be expressed as shown here. The result implies that large tidal bars would generate lower pitch sound than smaller ones. This analytical expression is then compared here with the experimental results for several values of the void fraction C. The comparison shows that the rumble sounds generated by the breaking bar have a low frequency pitch comparable to the sound generated by collective oscillation of rising bubble clouds. The low rumble frequency may explain the general public perception of approaching breaking bar as galloping horses on locomotive trains. In summary, a tidal bar is a powerful estuarine process with related geophysical and man-made processes. A basic understanding of the relevant processes, including sound generation, is critical and discussed in a number of relevant YouTube video movies.